and welcome to 5-Minute Science. Today's topic is weathering. Now, weathering is a really big topic, so for today I've decided to enlist some help from another earth science teacher, and with us today is Mr. Kiley, who's supposed to be here. Kiley? Kiley? Kiley! You ready to do this?
Oh, I'm ready.
Let's do this. Watch out for the dog nuggets.
So I had eggs, pancakes, sausage, an omelet, bacon.
Maybe you had too much breakfast. What are you doing down there?
So we'll put a tree here.
Nobody planted a tree here. See, what happens is that the seeds get into the cracks in the pavement, and then when the tree grows, it breaks up the concrete. It's a type of physical weathering. It's called root wedging. Come on.
I still think that's a stupid place for a tree.
So remember, in the future, vegetation can be dangerous.
I know. It's really my own fault. I need to watch where I'm going.
That was all. Dude, you seriously need to watch where you're going.
What happened?
I think you fell into the biggest pothole in North America.
How did it get here?
Well, water gets into the cracks in the pavement. And then when it expands, it freezes and it breaks up the rock.
Wow, this is ridiculous.
This is a big pothole.
Wait a minute. Ice expands when it freezes? How does that happen?
I'm not really sure.
I am Mother Nature. What question do you have of the natural worlds?
Well, for starters, could you turn that down a little?
Oh, sorry. What would you ask of nature?
We'd like to know why water expands when it freezes.
The water molecule consists of a single oxygen atom and 2 hydrogen atoms. They are strongly bonded with covalent bonds. Water molecules are attracted to each other by chemical bonds between the negatively charged oxygen and the positively charged hydrogen. As water cools below 4 degrees Celsius, the hydrogen bonds pull the negatively charged atoms apart, creating a crystal lattice structure referred to as ice. Did you get all that?
Yes, thank you very much. That was lovely. I have an idea. Why don't we actually run an experiment?
Okay. If this is true and water does expand when it freezes,
Pothole.
if water expands when it freezes, I'd like you to prove it.
Okay, well, my idea was that if we take this bottle of water and we put it in the freezer overnight, in 12 hours, it should be ice. And then...
All right, so water level's up to here.
Mm-hmm.
Let's see if it goes up and it actually does expand.
Worth a try.
Whoa, ice cream! Can we...
This is for science.
Sorry.
See you in 12 hours.
Oh, good morning.
Coffee?
No, thank you.
Should we see if this worked?
Oh, our experiment, yeah.
Whoa, look at this.
Wow. Look how much it expanded. Look, the water level went from here all the way up to there.
Yeah, and the bottle totally warped from the change in volume too. That was so cool. Are you eating all my ice cream?
John had some too.
Next time I'm locking the fridge.
Oh, pizza! Can we make that?
For breakfast? Ew. Ice cream for breakfast is pretty gross too.
So anyway, another way that rocks tend to weather is biologic activity.
Wait, you mean like bugs and worms?
Yeah, pretty much anything that burrows will do it. Hurts, doesn't it? Oh, look, rust.
Really? You're in serious trouble now.
No, you're missing the point altogether. This is a new type of weathering, chemical.
So you're talking about a chemical change instead of a physical one?
Exactly. A physical change is when we break things down piece by piece.
Okay.
A chemical change is when we're going to change the composition entirely.
Oh, okay, like what iron oxidizes. Like this.
I have no idea what that is.
It's actually not just iron that oxidizes, pretty much all metals oxidize.
Really?
Mm-hmm.
Like what?
Let me show you. And we are magically in Central Park, as you can probably tell by the carousel music. Anyway, if you look behind me at that building, no, not the skyscraper, the other one. Right? You see the one with the green rooftop? Well, that rooftop wasn't always green. It was originally made of copper. In fact, it still is made of copper, but the copper oxidized. So iron, when it oxidizes, turns into a rust color. But copper, when it oxidizes, becomes the strange green color. And I have an even better example of that in New York. The Statue of Liberty, which is, well, it's over 125 years old at this point. But when it first arrived here, it was copper colored because that's what the outside is made of. It's actually completely covered in a sheet of copper plates. The reason it's green, oxidation, just like the rooftops in Central Park.
Whoa, how did you do that?
Magic.
Magic. I knew it.
Wait, I'll do it again. Okay, so now I am in a cemetery. Festive. Where's Mr. Kiley? Kiley? I guess I have to work on that one. Anyway, John's here. So if you look at these headstones, you can see that the writing is practically gone. That's because these are made out of marble or limestone, which dissolves easily in acidic water like acid rain. Now humans create acid rain through carbon emissions. Water combined with carbon dioxide creates carbonic acid. Nowadays we tend to make gravestones out of granite, which is much more resistant to chemical weathering. But 100 years ago, that really didn't matter. So I have really no idea who is buried here, which could be really dangerous during the zombie apocalypse. We should go now.
Guys? John? Cecily? Where'd everybody go? Oh look, rust.